This is a net ionic stoichiometry problem. So the first thing I need to do is get it from words into symbols and then write the net ionic equation. So lead 2 nitrate is Pb, and then I know that nitrate is NO3, which has a -1 charge, so I need 2 nitrates to balance out the +2 from the Pb. And then that's going to react with the potassium iodide, which is Ki. K is +1, I is -1. And so then when I double replace, I end up with PbI2 and potassium nitrate. Now when I look at this reaction, I can see that these solutions, and these are both solutions, from reading down a little further, I know that it creates, well, KNO3 is a solution because potassium nitrate's always, alkali metal's always soluble, nitrate's always soluble. So what's left in this reaction forms a solid, tells me it forms a solid, has to be lead iodide. And lead is one of those heavy metal guys that's normally going to form your precipitate, form your solid, unless he's with nitrate. So to write the net ionic then, very simply, I'm going to write the solid, the PbI2. And I'm going to write the ions that had to come together to create that solid. So some lead, and because there's a 2 on the iodine, there's going to have to be 2 I-1s. So that's the net ionic equation. And so that actually helps me answer a question that's a little bit further down here that says, what is the formula of the solid? Well, that's the PbI2. So then in the lab description, it tells me that we have some filter paper, that we filtered everything and we let it dry. And the first time we weighed it, it weighed 9.239. And the second time we weighed it, it weighed less because it wasn't done yet. It wasn't done drying yet. So anytime you see this first weighing and second weighing, just if you're careful, if you really read it, if it's weighing to dryness, you mark out all the weighings except for the last one. So now I've got my problem to figure out. It says B, how many moles of solid was recovered? Well, the first thing I need to figure out is how many grams of the solid was discovered or recovered. And so I know that the filter paper in the solid is 9.234. So I just need to subtract the filter paper from the filter paper in the solid. And so when you do that simple subtraction, you end up with 8.228 grams. And so I'm going to start there. So my moles, my grams of solid recovered is 8.228 grams. And I know that's PbI2. So then all I'm going to do is convert that to moles by dividing by the molar mass, because I know that 1 mole, if you look up the molar mass of PbI2, pretty heavy compound because both lead and iodine are pretty heavy. So when I divide that out, you end up with a small amount of moles, 0.01785. I have quite a few numbers here because there's several numbers in my lab data. So I have 4 significant digits and I have 4 significant digits in my lab data. So that's my moles. And so then C is just asking us to do basically a simple stoichiometry problem. I know my moles of Pb, and I'm looking for, if we kind of go back up to the original equation, if I go back and I balance that one, I said I have 2 I's. I need 2 Ki's, and I get 2 KNO3s in the molecular equation, the full equation. So I know that for every 1 Pb, I have 2 Ki's. So all I'm going to do is now take my moles, so my 0.01785 moles of PbI2, and I'm just going to convert that to Ki. So I know that I have 2 moles of Ki for every 1 mole of PbI2. And so I know that my moles of Ki, just double that number, 0.03570. So that's my moles of Ki. And then I'm just going to convert that to grams because it's asking me for how many grams. And so we could have done that in one step on the dimensional analysis. Dimensional analysis is not required. You just want to be able to kind of show your thinking. So I know that there is 166 grams, the molar mass of Ki. For every 1 mole of Ki, again, I'd have less than a mole. So I'm going to have less than 166, and that comes out to be 5.93 grams of Ki in this problem.